Like resistors, cells can be connected in series and parallel combinations. By simple calculation, we can easily find potential difference between points A and C. Epsilon 1 equals to EMF across first cell. Epsilon 2 equals to EMF across second cell. R1 equals to internal resistance across epsilon 1. R2 equals to internal resistance across epsilon 2. I equals to current flowing through circuit. Now let VA equals to potentials at points A. VB equals to potentials at points B. VC equals to potentials at points C. Now VAB equals to potential difference across AB. VAB is equivalent to VA minus VB equals to epsilon 1 minus IR1. Similarly, VBC equals to potential difference across BC. VBC is equivalent to VB minus VC equals to epsilon 2 minus IR. Now potential difference between the terminals A and C of the combination is VAC is equivalent to VA minus VC equals to VA minus VB plus VB minus VC. VAC is equivalent to epsilon 1 minus IR1 plus epsilon 2 minus IR2 is equivalent to epsilon 1 plus epsilon 2 minus IR1 minus IR2. VAC equals to epsilon 1 plus epsilon 2 minus IR1 minus IR2. VAC equals to epsilon EQ minus IREQ. For series combination, epsilon 1 plus epsilon 2 equals to epsilon EQ and R1 plus R2 equals to REQ. Cells can be connected in parallel also. Here also we can find equivalent EMF and resistance between points B1 and B2 by simple calculation. Considering parallel combination of the cells, I1 and I2 are the currents leaving the positive electrodes of the cell, the current flowing through the circuit in I. Then I equals to I1 plus I2. Let VB1 and VB2 be the potentials at B1 and B2 respectively. Then potential difference across its terminal for cell is V equals to VB1 minus VB2 equals to epsilon 1 minus I1 R1. Similarly, potential difference for second cell V equals to VB1 minus VB2 equals to epsilon 1 minus I2 R2. V minus epsilon 1 equals to I1 R1. I1 equals to epsilon 1 minus V upon R1. V minus epsilon 2 equals to minus I2 R2. Now total current I equals to I1 plus I2 equals to epsilon 1 minus V upon R1 plus epsilon 2 minus V upon R2, epsilon 2 minus V upon R2. I equals to epsilon 1 upon R1 minus V upon R1 plus epsilon 2 minus R2 minus V upon R2. I equals to epsilon 1 upon R1 plus epsilon 2 upon R2 minus V 1 upon R1 plus 1 upon R2. I equals to epsilon 1 R2 plus epsilon 2 R1 upon R1 R2 minus V R1 plus R2 upon R1 R2. Now V equals to epsilon 1 R2 plus epsilon 2 R1 upon R1 plus R2 minus I R1 R2 upon R1 plus R2. V equals to epsilon EQ minus IR EQ, where epsilon EQ equals to epsilon 1 R2 plus epsilon 2 R1 upon R1 plus R2 and REQ equals to R1 R2 upon R1 plus R2. Simpler way of equation: 1 upon REQ equals to 1 upon R1 plus 1 upon R2. Epsilon EQ upon REQ equals to epsilon 1 upon R1 plus epsilon 2 upon R2.